Welcome to Get Your FRQ On. This question is from the 2002B exam. It's question 1, and it is calculator active. In the question stem, we have two functions, a linear function and a rational function, and we have their graph. And on the graph, there is a region R defined between the two curves. In part A of this question, we are asked to find the area of that region R. So from the graph, it's pretty obvious which function is above the other one because they're labeled, but we don't know the bounds of integration yet. We have to figure out where these two graphs intersect so that we know the bounds of integration. Now, one of the bounds is just going to be 0, right? That's just the way that the region R is defined. Right, so because this is a calculator active question, I can use my calculator to determine when these two functions will intersect again. When will x cubed over 1 plus x squared equal 4 minus 2x? Use your calculator. They will intersect at 1.4876644. And for just brevity's sake, I'm going to call that number s. Right? And the reason I'm going to do that is that's going to be one of my bounds of integration. I don't really want to keep writing that number all over again. It's just going to be easier if I define it to be this value s and then refer to it using that value s. All right, so the area of that region R is going to be the integral from 0 to s of my upper function, which is 4 minus 2x, minus my lower function, which is x cubed over 1 plus x squared dx. And again, this is a calculator active question, so you're going to use your calculator to do this. I don't think you want to do this by hand. It's a calculator active question. Why would you do that unless you just enjoy it, but not expect it on this exam? Using a calculator, that area is 3.215. In part B of this question, we are asked to find the volume when this region R is revolved around the x-axis. All right, so since we're revolving around the x-axis, we're going to let our big radius function be 4 minus 2x, since that is the function furthest away from the x-axis, and our little radius function be x cubed over 1 plus x squared, since that is the function closest to the x-axis. And then we can find that volume of revolution by taking the integral pi times the integral from 0 to s of my big radius function squared minus my little radius function squared dx, and that turns out to be 31.885. And one thing I do want to point out is if you define your big radius function r and your little radius function r in your work, you can write the integral in terms of big R and little r. If you don't do that, then you shouldn't be writing it in terms of big R and little r, since the reader will have no idea what you're talking about. But because we did define this, I can write this integral a little bit more briefly using those names instead of the actual functions. It is a calculator active question, so you would need to show what integral are you asking your calculator to evaluate, but since I've already defined these two functions, I have the liberty of referring to them in my integral. If I don't define them, I do actually have to use the function definitions in order to write this, which is no big deal. It's not that difficult to do, but it sometimes helps to define these things ahead of time, since you may need to refer to them more than once. In part C of this question, we are given that R is the base of a solid and that cross sections taken perpendicular to the x-axis are squares, and we are asked to find the volume of that solid. All right, well, since cross sections are being taken perpendicular to the x-axis, we're going to integrate with respect to x, and so the volume that I want is just going to be the integral from 0 to s. Again, notice I'm using s instead of the number 1 point whatever that was. And now the cross-section area is the difference between big R of x and little r of x, and then the area, which would be that squared. So I have the integral from 0 to s of big R of x minus little r of x squared dx, which is 8.997.